And so last week we have already begun our discussions on QR algorithm, and the QR algorithm here we have first of all, we are going to transform the things here. We are going to generate a sequence of the matrices from the QR algorithm. And then this is the first one, the original one. And then we have a tridiagonal matrix. And we are going to use the QR algorithm to get a sequence of C matrix. At the end of the day, you will get a sequence of matrices. They are still tridiagonal, but the things, so for the B2, B3, and Bn number here, they are the off-diagonal elements, and then the value of them will become smaller and smaller, and it's going to zero, those numbers, the off-diagonal numbers. And at the end of the day, if these numbers are going to zero, and then we just have the eigenvalues on the diagonals, and then that is the A1, A2, A3, and An. And this is the idea of the QR algorithm. And last time I just introduced several things. Some things that is the and the QR algorithms. The idea is to, so if we have a matrix here A, and then we would factorize it into a product, and then that product is C, an orthogonal matrix, and the R1 is a upper right triangular matrix. And then now with this factorization, we are just going to define another A matrix, and then that is the A2. And the generations process is just the switching the order of the R1 and Q1 here, and then we get a new matrix. And this is the A2. And with the A2 here, and then I am going to do the QR factorization again. And I got the orthogonal matrix again, and then and this is upper right triangular, and then I switch the order of the R and Q, and then I generate the A3, and then I will continue this process. And there's one question from the class after the last week's class, and then one student is asking, we saw something here, and then the A1 equals to Q1 R1, and then QA2 equals to Q2 R2, and then there's one question is asking, is it the Q1 equals to Q2 R1 equals to R2? Actually, they are not equals. They don't equals, but because if you take a look at here, if we switch the order of R and Q, actually this A2 is different from the A1. They are different matrices, and then so if you are going to get factorizations of the A2, and then you would get a different matrix. This is different. The Q2 should be different from the Q1, and then R2 should be different from the R1, because A2 and then A1 they are different. And this is the general idea, and then I have give you some property about the sequence of the A, and then we have A is symmetric, and then A has the AI plus 1, and then has the same eigenvalue as the AI, and then the AI plus 1 is still tridiagonals throughout this whole process. And so the next topic is how to get that QR factorization. And as we can see from the these things, so AI plus 1, and then it's just equals to the QI transpose, and then times the AI, and then times the QI. So the important things is to get the Q matrix, the orthogonal matrix. And we just mentioned a little bit about the Q matrix generations process. We are going to use a sequence of the rotations matrices to generate the Q matrix. And last time I give out the definitions of the rotations matrix, and it's pretty similar to the identity matrix, but in the I row, this is the I row. Let me see. This is the I row, and then this is J column, and then we are going to put the cosine theta and sine theta values in the I row, J rows, I columns, J column here, and then just change a little bit, change 4 elements in the identity matrix to create such an rotations matrix. And last class, I also give you one examples to find out one rotations matrix P such that we have zeros at the desired component, and that is the AT1. And we have used some property in the calculation. If we multiply the matrix A with the P on the right, and then we are just changing the values in the A, in the I column, J column, but if we are going to multiply the P on the left, and then we are going to just changing the values in the I row and J row. So here we showed the calculations last time, and this time we are going to use such an idea to generate the matrix we want. So at the very beginning, what matrices do we have? And let me just copy down what we have at the very beginning. This is the A1. So now I'm going to generate the matrices we want, the A2. And the A2 here, I'm going to just try to remove some things. Okay, good. So here I am going to do some factorizations here. The idea is to remove the B2. So here I'm going to get the same idea here. This example is to get the A21 to be 0, right? So I have the same idea here, and then but for this big matrix here, I'm going to get, so I'm going to get the P2. Let's get the P2. Let's get a rotation matrix P2 such that the A21 equals to 0. If we do the same calculations here, and then you can do the details calculation here as the examples, example 1 here. And I would just tell you the result, and then so I'm going to have, what is the idea of the factorization here? So we are going to do the factorizations A1, right? And then equals to the Q1 and the R1. And we are going to generate a sequence of the rotations matrix, and then such that the R1, and then it's equals to, so what is the R1? R1 is just the upper right triangular matrix, right? Upper right. So we are going to generate a sequence of the rotations matrix such that we use the P to denote the rotations matrix here, and then such that the Pn times the Pn minus 1 all the way to the P2 and then A1. And then, so which means that, so at the very first step, and then that is the P2 rotations matrix times the A1, and the next step is the P3 times the result, P4 times the result here. And then at the end of the day, this is the desired result R1. R1 is upper right triangular. Which means that we are going to eliminate the elements below here one by one, we are going to let this to be 0 at the first step. And then second step, we are going to get this part to be 0. And then at the end of the day, this one will become 0. And we get the upper right triangulars matrix. So for the first step, we are going to get one rotations matrix P2 here, and then the P2 times the A1. The result here, we would get a 0 at the A2 one elements. So now let's see, what do we have here? You can just mimic what we have in the examples 1, and I will just tell you the result. So let's choose, let's say choosing the rotation matrices P2, and then once again, this is a rotation matrices, and then we want to just change the value A to 1 to 0. So which means that we can choose the value here, and then that is the P11, P22, because we are going to change the row 1 and row 2, and P12 equals to the P21, and then the sin theta 2. This is just from the definition of the rotations matrix. And then now we are going to, this is quite similar to what we have here. We are going to decide the sin theta value, the cosine theta value, and once again, we need to have, because if you take a look, we do the multiplication here. If we do the multiplication here, and then you would find out that what is the A21, the matrix multiplication, the P2 times the A1, and then we are going to require the 2, 1, that is the element of this matrix that at the positions 2, 1, and then we require this to be 0. And which means that we require the negative sin theta 2, and then A1, and then plus the cosine theta 2, and then B2 equals to 0. And also we combine one matrix, one identity here, sin theta 2, and then square, and then plus the cosine theta 2, and then square equals to 1. And if you go to solve this equation, and we would get such a result. Sin theta 2 equals to B2, and then square root of B2 square, and then A1 square. And the cosine theta 2, it equals to the A1, and then square root of B2 square, and then A1 square. So at the end of the day, you would get zeros. So at the end, we would get a matrix, and then that is not the A. So I'm going to use the notation here, so in case that you would get confused, and then I will explain my notation a little bit. So here, our goal is to generate, the QR method here is to generate a sequence of matrices. This is the original one, and then this is the second one, and then this is the third one, right? But inside this iteration, I am going to load this. So at the very first, and then we get the A1, and then after one rotations matrix P2, and I'm going to use the subscript here to know the result, but this is in this iteration. So I'm going to use subscript here, and then that is the second matrix I get from this iteration, okay? And I'm going to get one more rotations matrix here, and it will give me another matrices inside this iteration. And at the end of the day, so I would get all the zeros in the below the diagonals. So this is the PN here, and then Pn minus 1 here, and then all the way to A1. And this is the things. And I got this one should be a upper right triangular matrix at the end. And I will give you some result here later on, upper right. Okay, this is the idea, the notation. This is the second matrix inside this iteration. And this is not the same as this one, okay? So this is just one matrix inside one iteration. And this is the bigger iteration here, the bigger loop here. So this is the notation. And next, I'm going to take a look what we have. And so at the end of the day, so after these iterations, what we get is some zero here. And I'm going to take a look what we have. And the idea is we just change the value here. And but the A1, A2, some things are updating here, because actually we are updating the value here. So let's say we have the Z1 here, because we have already changed the value. And then let's say we have the Q1 here in the first row, and we have a 0 here. And we also change the value here. And let's say this is X2, and then this is the Y2. And actually, because we have already do some row addition, summations, and then row subtractions here, multiplication here, and then we are doing some operations in between these two rows. And actually, we could have some non-zeros value here. This makes sense because we do some subtractions and summations between the row 1 and row 2. This makes sense. So here it could be non-zero this time, because I can use the row 2 and then add to the row 1, right? And then this could be as to that positions, and then it could be non-zero this time. So I'm going to use R1 to represent this number. But the good news is that we have 0 here, 0 here, and then I think this is our goal, and we want to get this part to be 0. And the next thing, okay, this is the A21, and this is the second matrix inside this small iteration. And the A21 is just the this one is just the P2 and then times the A1 matrix. This is just one rotation matrix. The matrix get after the rotation, and we get this one to be 0, and then this is the results matrix. And the next part, we are going to get the P3 and then get this part to be 0. Does it make sense? The same process, right? We create the rotations matrix, and then we have the sine theta, cosine theta in the third row, and the third row, and the second row, and then third column, second column. And then we are going to calculate this number, the sine theta and cosine theta, in the same way, and then we would get the desired matrix, and then to get this part to be 0. And I'm going to give you the general process here. So let's say in general, I'm going to give you the idea how to generate such a sequence of matrix inside one small loop. And then after this loop, and then at the end, the goal is to get an upper right triangular matrix here. Let's see. So let's say in general, the matrix here, we already get a matrix. The matrix PK is chosen to, let me see. In general, let's say we have this matrix, the matrix AK1, and that is something in between these processes here. And then we have already get a AK1, and then the AK1 has the format here. And then let me see, it's not good to draw this picture. This matrix, let me just write it down. Okay. We have the J1, Q1, R1. I just say, okay, after the rotation, naturally, we have some new value here, and then J1, Q1, R1. And if you take a look at the value here, that is the diagonal elements, and then the two elements after the diagonal. So if we arrive to the AK1, we have the same thing happening. And then we have the J1, J2, and then J3, and Z1, Z1, Z2, Z3 here. And then we also have the two elements after the diagonal, Q1, R1, and we have the Z2, Q2, R2, and all the way to, all the way up to, let me see, this is, and all the way to, so let's see, I'm going to write the diagonal here. So the position, let me write it here, the JK1, the JK minus 1, JK minus 1, and then QK minus 1, and then RK minus 1, and they are all above the diagonal. And the other things, all the rest of things to the right, it should be 0. And here, below here, we get the XK and YK. If you take a look at the second, the first situation itself, we get the X2 and the Y2 here, and you could see we have a 0 here, and then we have a 0 to the right. So the same as the AK matrix, we get a XK here, and then YK here, and then all the things in this rows are 0. The other things are 0. So I get XK, and then YK here, and then 0 here, and then all the 0 here. And the things below here is unchanged because we haven't changed the things below here up to this steps. So this is just the B3, A3, and then this is the B4. And I have nothing's, I haven't changed anything below this row. And I just copy the things here, BK plus 2, and then all the things to the right are 0. Okay, and all the way to the BN, and then BN, and then AN. And let me see, I'm going to point out the diagonal here. This is the diagonal. This is the diagonals here. And then all the things below here should be 0. 0. And another 0 here. 0, 0, 0, 0. And then this one, it could be not clear. The matrix is a little bit tilted here. If you cannot write my understand my writing, and then you can take a look at the textbook's matrix representation here, there. And so this is the AK1. That is just one matrix inside this iteration. And our question is that how to get to the AK plus 1 in this small iterations. And the question is that, okay, let's get the PK plus 1 rotations matrices, rotations matrix. And we want to let the PK plus 1, so the AK plus 1 and then 1, and then that is the rotations matrix times the AK1, that is what we already have here. And then we want to calculate that PK rotations matrix such that we want to get this part to be 0. And that is, we let this k plus 1 row and then and the k columns element to be 0. And our goal is pretty clear. And then the identity, this pk plus 1 rotations matrix, it could be written in this way. And then we divide it to several block. And then on the upper left, and then it's just the identity matrix. And then the in the lower right, and then we have another identity matrix, and then its dimension is n minus k minus 1. And because we want these to be 0, this is the k plus 1 row and then k column. So we are going to create some value here, and that is the cosine theta, negative sine theta things, and that is in the k row, and then k plus 1 row, and then k column, and then k plus 1 column. And we just write down the value here, and then this is the ck plus 1. This one is the cosine value, but I'm going to use the c to write the value here. We have ck plus 1 here, and then this one is the same as this one, and then this is the sine theta value, and then this is the negative sine theta value. And I just give you the this is the 0, 0, 0, 0, 0, 0 here. If you take a look at the rows it is in, and this one is the k plus 1 row. This is the row k, and then this is the row k plus 1, and then this one is the column k, and then this is the column k plus 1. This is because we are going to change the values such that this one, the k rows, and then k plus 1 row, and then k columns elements to be 0. So we are going to have this rotation matrix here. And let's see. So this is something after the calculation, and the goal is very clear. We want what's going on? Create. Okay, good. So what is the goal? The goal is a k plus 1, and then the we want the k plus 1 element, and then the k column element to be 0. This is our goal. And if you do the calculation here, and then let the pk plus 1, and then times the ak1 we have here, and at the end of the day, you are doing the same calculations here. We would do the same calculation here. We would have a formula, and then this is the requirement, right? The 2, 1, and then equals to 0. And then we have such a formula equals to 0. And then we also combine it with the identity formula, and then we solve for the cosine number and then the sine number here. And we are going to do the same thing, but I'm going to skip the calculations here and just give you the result. And at the end of the day, so result is the xk plus 1, it equals to the number bk plus 1, and then divided by the square root bk plus 1, and then square, and then plus the xk square. And this is the important part in the QR algorithm, how to decide the rotations matrix. And then this is k plus 1, and then xk, and then square root of bk plus 1, and then square, and then plus the xk square. And at the end, so let's see what we have at the end. After the multiplication, and then we get a format, and then it's updated matrix. And so let me just copy down what we have here. This is the AK. This is the AK, and don't forget that we are just changing the K row and K column here. So which means that if you take a look at the matrix, the new matrix, what do we have at the end? So we just change the K row. We just change the K row. And then this row here. And so this is the new matrix AK plus 1. And we have, once again, we are going to have the 0 below the diagonals. So here we have ZK. ZK, it should be the diagonal things. It should be here. ZK, and then we could have QK here, and then we could have one non-zeros element here as well. And below here we have, so here we have the 0 here. This is because this one, it is the K plus 1 row and then K column. And then this is our row. In this calculation, we want this one to be 0. And here we have the X K plus 1 and then 1K plus 1. That is another values after the multiplications, the matrix multiplications, YK plus 1. And then to the right is just 0. And below here, all the things are unchanged. So I got, it should be the AK. So here, below here, it should be the same things, AK plus 2. And then I got the BK plus 3 here, and then BK plus 2 here. And then all the way down to there. So all the things just get changed in the row K and row K plus 1, and then all the things below here, they just remain the same. And then the things above here, they stay the same as the one we have in the AK matrix. And any questions by so far? So we just, the idea, you can take a look at the matrix, they are very complicated, but the idea is to just get the K plus 1 row and then K column element to be 0. And now up to K iterations, and then you can see all the things below here up to this this element, and then all the things below the diagonals become 0. So we expect that after n iterations, all the things below the diagonals become 0. And so that's the things. So we are going to get at the end. So if we keep proceeding to construct the rotation matrices. If we keep proceeding there, if we keep proceeding to construct the rotations matrix P2 and then to the Pn, and this way, and we generate, if we keep constructing the rotations matrix P1 to P2 Pn, and we at the end we get this. We get the AN. That is the things we have here, the AN1, and we expect this one to be an upper right triangular matrix. This is the upper right triangular matrix. And that's the things we want in the QR factorization, and then we call it to be, so we define it, I use the triangle above the equal sign here to say this is the definition. We define this one to be our upper right triangular matrix in the QR factorization. And this matrix is just the upper right matrix, and then it's with the format. We have the ZQ1 R1 here, and then Z to Q2 R2 here, and then all the way to the, so this is the all the way to the XN. And then we have the QN minus 1 here, ZQN minus 1 here, ZN minus 1 here, and then here we have RN minus 2. There's something's not very good here, the writing. So let me move it down. Okay, good. So the diagonals is this one. The diagonal is this one. Although the matrix is tilted here, this is the diagonal. And then the other things is the non-zero, it could be non-zero elements in this matrix, the Q elements and the R elements. So as you can see here, we have a diagonal, and all the things here, it could be non-zero, and then all the things here, it should be 0, and then all the things below the diagonal are 0. So this is the matrices we want, and this more iteration, we get the upper right triangular matrix. And at the end, if you take a look at this one, and then we get the R1, right? And then what is our goal? We want to factorize the A matrix. This is the original matrix, right? A1 matrices, and then we want to factorize it into the Q, and then 1, and then R1. We already get the R1, and then what's the R1 here? Let's take a look. What is the R1? The R1 is actually equals to, so at the very first, we do some things to the A1, and that is multiply the P2, the rotations matrix P2, and P3 here, and then there's the P3 rotations matrix, and then we keep doing such a things. So the AN1 is just the all the way to the PM matrix. So we are going to do the rotations matrix one by one, and the P2, P3, and then all the way to the Pn. And this is the matrix, upper right triangular matrix here, and then that is the same as the AN1. This is by the definitions. So let's see what's the Q1 matrix here. If you take a look at here, and then it's actually the Q1 could be defined in this way. The Q1 is just a Pn transpose, and then Pn minus 1 transpose, and then all the way to the P2 transpose. This is because if you take a look at the multiplication here, the P2 transpose, and then all the way to the Pn minus transpose, and then Pn transpose, and then times the R1 matrix. What is the R1 matrix? The R1 is just a Pn, and then P3, and then P2, and then A1. And if you take a look at the multiplication here, Pn minus 1, and if you take a look at the multiplication here, because this is the rotation matrix, and then the rotation matrix is orthogonal. And so this multiplication is just the identity matrix, right? And this one is identity. This one equals to the identity matrix. And now there's the same things happening to this one. It's like a telescope. This one times this one, and this is still orthogonal matrix, and this identity, and then we treat it as an identity, and this one times the identity, and then times this one, and then it's still identity matrix, right? So now, if you keep doing the multiplications from the middle to the right to the left, and then we get these whole things here. It's just the identity matrix. Does make sense? So this gives us, at the end, this is just the A1. So this is what we have here. The Q1 matrix times the R1 matrix is the A1 matrix. We don't change anything if we do this modifications because they are the identity matrix in between. That's the things. This is the Q algorithm. And so actually we can define the Q1. This is the definition of Q1. You can also define the Q1 in this way as well. Let me see. Let me just keep the Q matrix in this way. So this is the idea to generate the Q matrix. So let's take a look at one concrete examples to apply this algorithm. So you already get the Q1 and then R1 matrix, and this is the Q1 matrix, and then this is the important things in the algorithm. And after the Q1, and then we are going to get the A2 by switching the Q1 and R1. And this is the factorizations we get. We get the QR factorizations. We already get the factorization for the first matrix. And at the end, so we define the A2, and it's the R1 and then equals to the Q1, and then we would do the same process. We are going to do the same process to the, going to do the same QR factorizations to the factorizations for the matrix A2, but we are not repeating the whole process here. And this is how the QR algorithms work. And then do the QR factorization and then get a new matrix in the iteration. And but now let's take a look at one concrete examples how to apply all the algorithm here. This is the example 2 on the textbook, and we are going to use just apply one iteration to the of the QR methods, and then the matrix is defined with the A3101311013. And now, first of all, we already have the same example here as the example 1. So this is the matrix we have here, right? The first step is to get the A21 to be 0, this element to be 0. And we already calculate the cosine theta and sine theta value here is square root of 10 over 10, and the cosine theta is just a 3 square root of 10 and then over 10. And the P matrix, it looks like this. So I'm going to copy down this result because this is just the first sub iterations in this small iteration here. So I'm going to copy this down. In the example 1, so solutions. In the example 1, we already found out that the P2 matrix, and then the P2 matrix is just 3 square root of the 10 over 10, and this is the results from the last class, and that's square root of 10 divided by 10, and then negative square root of 10 over 10, and that's 3 square root of 10, and then 10, 0 here, 0 here, 0 here, 0 here, 1. This is the P2 matrix. What is the A21? So here we have the A21. It's just equals to the P2 times the A1. So now we are going to do such an calculation here, P2 times the A, or we can call this one is A1. So this one is just the A1,
and then A1 because the A1. A1 is just defined with the A. And now let us do the matrix multiplication here. And at the end, we get the result. It is this number, square root of 10, and then 3/5, and then square root of 10, and then square root of 10/10. And then we have the 4 square root of 10 here, divided by 5, 3 square root of 10, and then over 10, and then 1, 3 here, 0, 0 here. So this is the A21, and we are going to create the P3 matrix here to get a A31 in this small iteration. And let's see how to create it. I'm going to now get some notation here to make the calculations clear. So corresponding to our analysis, this is the Z1, Q1, and then R1 in the analysis. And then this one is just the X2, Y2 here. In the analysis process, this is the B31, and then this is the A31. We don't change the things below the second row, and then we just have the B3, A3 here. If you take a look at the algorithm, so let's get back to what we have here. We have, how do we calculate the things? The SK plus 1 is related to the BK plus 1 and XK. And so here we have the C1, Q1, and the R1, and then we also have the XK, YK here in the iteration. So let me just copy this formula down, and then you will see the how we apply this formula to that examples. So here, let's just do the plotting here. We are going to calculate the third matrix, the P3 matrix. And so here we have, this is S3, right? S3. And then we want to have the B31, then square root, and then B3, and then 1, and do the square. And then what is the XK? XK. Here the K equals to 2, so I have the X2 square. And I'm going to do the calculations later. And then the C3 here, it should be the X2, and then it's in the matrix 1. Here I also have the BK, B31, and a square. And then I have the X2 here. It should be the X2, and do the square. And let's get the values from the corresponding location. But B31 is here, it should be 1. And then the X2 here, X2, let's find out the X2. X2 value is here. The 4 square root of 10 over 5. And that's it. That's numbers I need in the calculations. So let me do the calculations for you, and then it should be. I'm going to just skip the whole process, the plotting here, but the value at the end, it should look like this, the approximate value, and then this one is 0.9299A. Which is correct because this is sine theta value, and then this is cosine theta value, and then it's between the 0 and 1. And that's how we calculate it. And this is the formula, you need to memorize it. And I'm not sure at this moment whether you need to memorize it or I put it on the cheat sheet. I'm not sure, but you need to understand the whole process here. So now, what is the P3 matrix? It's already A52, but the P3 matrix here, the A3 matrix here. So this one, A31, is just the P3 and then times the A21. And then what's the A3 here? This is a very important thing. So the A3, we just have the S3 and then C3. So if you take a look at here, this one is the identity matrix, 0 and then 0. And we have the C3 here. And then this is the C3 matrix, C3 value here. And then we have the S3 here and then negative S3 here. And you have the 821 here. So I'm going to skip the further calculation here, and then I'll keep the part to the next class. But this is the matrix we have for this rotations matrix, and then the C3 S3 value is calculated above here. Does it make sense? So this is how we do the QR factorizations. After this iteration, this one is already the R1 matrix. This is the R1 matrix. This is already the upper right triangular matrix. And I'm going to do the rest of things next time. I hope you can understand the process, how to calculate the S value and then the C value, and how to create that rotations matrix. Questions? And this is the concrete example. And then all the things above is just the analysis part. And all the things you need to know. And for the exam, for the homework, it's just this example. And class is over. If you have further questions, and then please come to ask me.哦，我收到了。
哦，对，然后
我刚刚收到了，今天早上。
对，如果可以的话，就是因为明天就得
哦，对对
交了。
对，我今天就弄。
好，谢谢太
嗯
谢谢。还有那个，我今天晚到2分钟，那个2分行吗？
可以啊，可以啊，可以啊，没事吧？那种叫做老客户优惠。啊！救命啊！ How to do the calculation? Do you understand?
No,
No 啊。
I need practice.
Okay.
Question. So P2 is here, right?
Yeah. Peter is calculated
And then
last
this is
time.
P3. So we made this to be 0 here.
Not making this to be 0. It's like what is the rotating the rotations matrix definitions? The rotations. This is the rotations matrix. Can you see it? So identity here, but we are changing. So for the P2, we are changing the first row and second row. So we have the C3, C2 here, C2 here, S2 here, S2 here, right? So what is P3? P3, we are going to get this value to be 0, right? The B3 one. So we are changing the value in the second row and the third row. And then which means that we have C3 here, C3 here, S3 here, and then negative S3 here, and then all the things, other things is just identity matrix again. This is not from the P2. This is just from the definition of the rotations matrix. If you take a look at the definition of the rotations matrix, it's here, right? And because I need your pen, because for the P2, what's the goal of the P2? Goal is to get the 821 to be 0, right? Okay. And we are changing the one values at the row 2 and row 1.
Oh, it's
right?
to make this 1 here to be 0.
Yeah.
Okay.
So we are changing the value to be 0 here, and then it's related to the I and J, and then I and J here is just a 2 and 1. And then if you take a look at here, the I and J here, right? This is the corresponding to I and J here.
Right.
So we have the C cosine value here, cosine value here, sine value here, sine value here. This is the first row, and then first row, second row, first column, second column. This is the I column, J column, I row, J row, right?
Right.
Okay, Good. Let's take a look at the P3. And then the P3, what is the goal of the P3? Is to get the B31. That is to get this location.
So it's A3 2.
Yeah. So let's say this is the matrix here, and then we want to get the, I'm going to just skip writing the matrices here because each time the matrix here is changing, but we are going to get A3 to be 0, right?
Mm-hmm.
And so it's related to the third row and then the second row, right?
Mm-hmm.
So I here equals to this one, maybe I or J, it doesn't matter. And then maybe this is I, this is J, right? And so we have the cosine value at the second row and this one.
It's third row, second column.
Yeah. We just put the C, the cosine and then sine value here. And then the other things, it's just identity matrix. And then this is our identity matrix.
Wait, I and J, they can be flipped?
They can be free, yeah. Because it doesn't matter, right? It's just the index.
Okay.
You have the cosine values on the diagonal.
Mm.
And then you have the sine theta here and then the negative sine theta here.
So the element you want to make it 0, just I plus 1, J plus 1. Yeah, right.
Yeah,
So for P4, it's gonna be the element 4 to 3.
yes,
0.
yes,
Okay.
yes.
Okay, I'll set it. Thank you.
Hi.
I had a really, I know like about the homework thing from last week. I sent you an email like of my homework